give you 40 minutes break, you know, to get dinner or whatever you want. It's 7 o'clock. We've only got 10 minutes between the classes, so I'm always going to give you a break in there. So you've got, generally I'll let you have this class early so I can get your roll taken on the second class. I'll let you. I've also got the sheets for ads for that one.
Oh, you do?
Yeah. I can pass those around. In fact, what I'll probably do on the ad list, I'll probably wait. I can't imagine 7 or 8 people are going to show for the second portion. I don't expect anyone else to show. They didn't show for this one, but I'll wait till lab. Usually I pass this out. It's instructor communication guidelines. Email works best with me, but there's some rules because we've had problems. As you can probably figure by what it says. Tactful and professional. Message should be well structured and subject should be short and descriptive. We say that because we've had some students get out of control and abusive and nasty, and you know, and unfortunately that's what this requires. They should be considered completely private, so anything you send to me is private. Let's see. But they should, okay, they're saying it should not be considered completely private because this stuff is saved in the system forever at some point. It is inappropriate to transmit email that contains any of the following: language that is defamatory, false, inaccurate, abusive, obscene, threatening, pornographic, sexually oriented, racially offensive, or discriminatory. So when you email between the instructors, keep it short and sweet and professional. Let's see. A message that violates or infringes on the rights of others are not allowed. Message that could or be considered sexual harassment. Message that appears to engage in acts of hostility, violence, obscenity, vulgarity, defamation, or otherwise implies criminal intent or illegal content. Their emails that are considered inappropriate may result in disciplinary, legal, or other punitive actions. So it's unfortunate we even have to say that, but I don't anticipate any problems. If you speak to me respectfully, I'll do the same. Any questions on anything so far? I don't really have anything else to cover. I'll let you take a break. But yes.
Do you put your PowerPoints online for your website?
I haven't, and I haven't really been doing that. Maybe I'm lazy, but what I have been doing is I'll usually have a couple of students who'll come up and I'll just plug it in because it can sit right here and I'll just transfer it over. The PowerPoints, everything that I put on the screen is in this 8803 book. So you're welcome to take my, and I do add a little bit of color and stuff and a few notes here and there, but for the most part, 99% of it's right out of your book. It's just highlighted. I'll look into getting something online, but I don't know, maybe it may not be this semester. Any questions about anything in aviation related? I don't think we'll have too much trouble, and I think this should go fairly smooth. I'm a little bit out of water on evenings in summer school, and I do make mistakes. I will speak before I think, so don't hesitate to correct me if I say something wrong, because I will. I will say something absolutely opposite. And I do appreciate it. Somebody says corrects me. Okay, what? This is next week's quiz, or actually it's not next week, it's Thursdays. And there's another mistake I'll be making frequently because normally when I teach this, it's once a week. I'm going to show you the test. This is the stuff that you will have found out in the reading, and it also gives me a chance to talk about it. But almost every test you get from here on out, or quiz, most of them, are going to ask you define an element. And it's any substance that cannot be broken down into a simpler substance, a substance composed of a single kind of atom. And define a compound. You will want to know the difference of these two. A combination of two or more elements. So water is hydrogen and oxygen, right? So water would be a compound. The element would be the hydrogen or the oxygen, because water is a combination of hydrogen and oxygen. That's two more elements. But those, the hydrogen and oxygen by themselves are not broken down into anything else. So that's the difference. Which subatomic particle is negative charge?
Electron.
Electron. And it's every test is going to ask you that. It'll ask you which subatomic particle is positive, which one is neutral. Or it'll ask you what are the three subatomic particles. That's fairly simple. Okay, what factor determines if a material makes a suitable conductor? And you're going to see this from time to time. I haven't, it's a little early. I'm not sure if I'll give you this quiz right away. Maybe I will, maybe I won't. It all depends on whether, I'm not going to do anything. I'd rather wait and cover more of this material. Does anyone know what a valence shell is on an atom? I see at least one, I see two. Okay, you know that you've got your nucleus and your electrons are in an outer ring. You've got your protons and your electrons, right? Neutrons. No. Thank you. Neutrons. And then the electrons are out here. And you can have any number of electrons on these layers. Everything I'm going to talk about we'll cover again. And I haven't decided. Maybe I might wait on the quiz. But these electrons, when we create electricity, it's the movement of electrons only. The protons and the neutrons remain stationary. And their movement across the wire is almost instantaneous. The reason being is it's like a domino effect. They push each other. Like, you know, there's rows of them and they move. So you don't necessarily have one electron going the full length, but they do tend to move and push each other. So the moment you get electron flow, you get an immediate response at the other end, almost no matter how long that conductor or that wire is. So a conductor is something that allows electricity to flow very easily. And an insulator is something that does not. Insulator is like, you know, the plastic around electrical wires. So what makes a suitable electron or a conductor, this outermost shell, this outermost circle on the atom is your valence shell. It's in your reading, V-A-L-A-N-C-E, valence shell. The fewer, and to me this is counterintuitive, meaning it's opposite of what it seems would be the correct answer. But the fewer number of electrons on the outer shell is the better conductor. The more electrons you have out here, the better insulator it is. I think it's counterintuitive because I think of the more electrons you have on the outer edge would be the more after movement, you know, mass current flowing. But it's actually the opposite. I think the way I have it in my head, and I don't know if it's necessarily true, is I think these are held in by the mass, almost like a gravity. Maybe not, but it's been so long since I really studied atoms. But I visualize it that way, that the fewer there are, the less they're drawn to each other. However you want to remember it. So in this answer, what factor determines if a material makes a suitable conductor? The answer literally is the few electrons in the valence shell or the number of electrons. You don't have to necessarily say fewer. What factor determines is the number of electrons in the valence shell. Fewer being the better conductor, more being the better insulator. Give it a good example of a conductor material. Should be able to think.
Silver.
Silver is a great one. Gold. Copper is widely used. I'm assuming so. I think that's used widely in fine electronics. Aluminum is actually a pretty good conductor. It's not as, I don't know if it's as flexible. Maybe it is. I don't remember I know aluminum is cheaper. It's not quite as good a conductor as copper, but it's still a pretty good conductor. But I wouldn't say it's ideal. So gold, silver, copper. You only need to give one. And this is a question that will repeat throughout the course. It'll ask you, give a good example of a good insulator, which might be glass, rubber, wood. What unit of measure describes current in an electric circuit? We haven't covered this quite yet. I've touched on it a little. What unit of measure describes current? Current is that river flow, that mass. It's amps. Ampere or amp. So the room's getting dark. I apologize for. Was it always this dark, or did you guys flip the lights off on me? I'm not going to brighten it up. But see, I want to bring a little more light in. That should be relatively painless. How is current calculated into direct current using volts and resistance? Okay, this we haven't, and I probably won't give you this one at all. I don't think it's fair. We haven't really discussed it. How is current calculated? If I want to think it's asking. I haven't looked at this since the beginning of my last semester. Current is calculated with I think volts divided by resistance. There's probably a couple of ways. Let me see what the answer is. Before I answer it.
Yep.
Voltage divided by resistance.
Divided by resistance.
Hey there. Yeah. For the lecture or the lab or both?
I just know it's this one.
No, we're doing 2 classes. This class is going to be over in about 20 minutes.
Yeah,
And then I'm doing a lecture that's related to this class. So if you want to come in and sit down, you're welcome to.
Sure. All right.
There's right in here somewhere.
Thank you.
Yeah, I'm gonna go easy. We won't do a quiz on Thursday. It's just, I was figuring I'd give you the answers now and you might remember and we'll do a little reading, but I'm not gonna hit you too hard. What is the meaning of the abbreviation EMF? And it's electromotive force. I think this is asked in the way out in the final. We'll see it a few times, but it's not hard to remember. You'll get it by then. It's my son. I just hung up on him. I'm okay with you guys taking calls. I know my son's home alone. He's special needs, but he's in good shape. I try to tell him don't call me unless there's a fire or blood, but he still calls me. Where's the remote to the TV? Okay, so with regard to voltage, what can be said about the positive side of a circuit? Okay, yeah, well, this is still way too early. I haven't been giving the first quiz. I've been kind of waiting in the past ones, and I just threw it in the day one, thinking I would prepare you to take it for next week, or there it is again, for the next class. But what I did say is that when electricity moves, it's only the electrons moving. So the positive side, I'm going to have to look at the answer to make sure I don't want to explain the wrong one. Okay. It is a deficiency of electrons. So we found that in a battery, we've always taught that electrons or voltage, electricity moves from the positive to the negative in a battery, but it really doesn't. We have always assumed early on we determined that there was a positive and a negative, and we've always assumed that the positive being greater always flows in the direction of negative, but that's not true with electricity. Since the electrons are the only ones that move at all, when we have that offset, if there's a shortage of electrons, they're actually, the positive side is more positive and the negative side is more negative. But since the electrons only move, the positive side is short, is deficient of electrons. Voltage is a pressure. So when we have a battery with a charge in it, between the two posts, there's more electrons on one side than the other. So as with a lot of things in nature, these things tend to want to equalize when they're given the opportunity. So since the electrons are the only ones moving, the electrons are going to move in the area where there are fewer electrons, which happens to be on the positive side. You don't have to remember this. This is just a nice to know. And we will, for the teaching of this class and throughout the world, we pretty much, everything that you ever look at will tell you that electricity flows between positive and negative. There's just too many manuals and diagrams that represent that. It just doesn't make a difference. Maybe somebody in NASA who's making super intricate electronics that are absolutely critical may factor that in. But as far as anyone in the rest of the world, it just doesn't matter. That's all I've got for that. So it's 1900, 7 o'clock. 7:10 is 7:50. I'm done. So if you want to stay for the lab, if you're going to do the lab,